Good afternoon. I'm Shahan Rahman, and today we are going to be discussing Titan and its atmosphere and the potential areas of study that we can conduct. I'm here with my group mates, Lucy, Kathleen, and Gabe. We're part of the atmosphere group. So, first, what we're going to do today, we're going to discuss what we currently know about Titan's atmosphere, just everything scientists and astronomers all over the world have gathered over the years. And then from there, we'll discuss what our group's main objectives are, what questions we're trying to answer. And then from there, we will discuss the various instruments we're going to be using in order to try and tackle these questions. And lastly, we will talk about how these instruments will help us answer the questions we are trying to answer. So without further ado, let me pass it off to Gabe.
All right. So we know that Titan's dense and hazy atmosphere is what makes this moon so intriguing and exciting to explore because it's a very unique phenomena in our solar system, specifically for a moon. And one of the most interesting discoveries scientists have made about this moon's atmosphere is that it is it's surrounded by a thick orange smog that makes it hard to see the planet's surface. We also know that the smog was produced, and this was through the process of nitrogen and methane molecules being split by the sun's UV rays. What's interesting about Titan is the fact that despite Titan's extreme distance from the sun, solar radiation still plays an important role in the atmospheric processes on Titan. It is important to note that this is a process that is continuing to happen today, and some of the hydrocarbon molecules that are produced are too heavy and fall to the surface as sand. As a result of the splitting that takes place in the upper levels of the atmosphere, a variety of hydrocarbon molecules are produced within this cloud, and these chemicals contribute to the different processes of Titan's atmosphere. Another very interesting thing that we know about the moon's atmosphere is that it is very nitrogen rich, as only 5% of the atmosphere is made up of other molecules, of which are mostly methane and other hydrocarbon molecules, such as propane and ethane, and even very small amounts of oxygen. This composition of Titan's atmosphere makes it very similar to the atmosphere here on Earth. So I'll pass it on to Kathleen.
Hi, I'm Lucy, and so these are our group's mission objectives, the questions that we have about Titan that we want to answer on this space mission. The first topic is regarding the possibility of an ozone layer on Titan. This is a fundamental question that we have when it comes to the study of Titan's atmosphere because it plays an important role in answering our group's second question about the possibility of life on Titan. The ozone process that is displayed on Titan is nearly parallel to the process that we see on Earth. Ozone is formed when the sun's heat and ultraviolet rays react with nitrogen oxides, also known as NOx, and volatile organic compounds, also known as VOX or hydrocarbons. The molecules in Titan's atmosphere are being split apart by the ultraviolet rays of the sun, like Earth. This type of chemical reaction can happen both close to the ground and higher up in the atmosphere. We already know that Titan's atmosphere is experiencing this, hence the orange haze that surrounds the moon. The haze is relatively young, so there is potential for change in the future, which is super fascinating. We don't get to see very much progression or shifting in this way when it comes to observing these solar system bodies. Studying how something might develop from how it is now would give us a lot of clues as to patterns of change and what might happen for the different times in this moon's life. And there have been surprising findings that support the assertion that Titan's atmosphere is very diverse in terms of the molecules present there, such as the discovery of C3H2. We are curious to further our knowledge about this because we want to know more about which molecules are present in that haze and whether this process could contribute to the formation of an ozone layer at some point in the future. Titan's process does differ from Earth's in that oxygen is missing here. So to bring us to our second question, we want to know if there is any point on Titan's timeline when it would be able to sustain life. Of course, this is one of the big questions that involves all the different complex pieces and qualities of Titan. Titan is such a unique moon in that its possibilities are so much more extensive than other moons. This question involves the atmosphere, liquids, the surface, and everything that this mission is aiming to study because, of course, life requires several different components to be able to take place. We are curious about what conditions this would entail and at what point in time this would occur if it was indeed possible. We know that life would look different on Titan because the building blocks for life are different there than they are on Earth. For example, liquid methane is present on Titan, whereas liquid water is present on Earth. There are certainly parallels between the characteristics and processes of Titan and Earth, but it is very possible that Titan wouldn't have to follow the same rules that Earth does when it comes to these processes. Through studying these aspects of Titan's atmosphere, we want to find out more about what building blocks are present for this crucial question. And our third question is about the methane that is in Titan's atmosphere. Is the level of methane increasing, decreasing? If its levels are being maintained, how is this able to occur? If there are shifts in the methane levels on this moon, we want to know how Titan will be affected by that change. Something else that we're curious about is the wide array of diverse chemicals that are present within Titan's atmosphere. We want to know what purposes they serve and how they got to be there. This would give us clues to both Titan's past and future. And finally, we want to know if the climate can heat up enough to reveal the ocean that is beneath its crust. And what is really interesting is that there's potential to be a moon changing and developing new things over time. We want to dive deeper into the details of Titan's atmosphere because it determines what that means for the and the life of the. And the atmosphere is just one part of the equation of all the questions about the surface and liquids and life come together to give us a more comprehensive understanding about Titan, what we don't know, and what we might discover. Will help us to find out more about how Titan used to be and the secrets of its current state and what its possibilities are for the future of this moon. And now I will be passing it off to Kathleen.
Okay, let me go like this. There we go. Okay, so the most important instrument for us is REMS, and this is short for Rover Environmental Monitoring Station. And REMS is a sort of orbiting weather station or slash laboratory, and it has 6 fields that it focuses on, which are recording aspects of Titan's wind. So for instance, its speed and direction, atmospheric pressure, relative humidity, air temperature, ground temperature, and ultraviolet radiation. So these 6 fields revolve around basically 3 components. And the first component is made up of 2 booms. And a boom is a kind of technology that measures the strength of infrared waves that radiate from surfaces. So the first boom would measure Titan's ground temperature. But the second boom, more importantly, measures the humidity of Titan's atmosphere. The second component is the ultraviolet sensor. And the third component is an instrument control unit, which is basically the heart and brain of REMS, and it controls all of the incoming data that REMS receives. So we know that Titan has this sort of unique orange haze, and no one knows for sure what this haze is made of or how it got there. And there is some thought that Earth may have had a haze that was similar to Titan's billions of years ago. So this is where REMS can be very useful. So along with REMS, another device that will be important in finding out more about Titan's atmosphere is TIGA. And TIGA is short for Thermal and Evolved Gas Analyzer. And it was first used on the Phoenix spacecraft, which was a Mars lander. And basically how it works is a sort of robot arm that is attached to the rover will take ground samples from the surface of Titan, then bring it back to TIGA, where the samples are heated at a really, really high temperature, about 1,000 degrees Celsius in a sort of oven. And this kind of oven isn't like a the size of a kitchen oven. It's really very small. And the heat causes the ice to vaporize into gases, which are then transported and sent to a spectrometer to analyze. And the spectrometer then can read isotope ratios for oxygen, carbon, nitrogen, and other sorts of heavier gases. And it has been described by the team that developed it as a sort of cross or a combination of a furnace and spectrometer. So we feel it's very important to gain knowledge of what is within that thick layer of ice that makes up the surface of Titan, and what exactly is that ice made of. And by hopefully getting a sample of what the chemical makeup is of that thick sheet of ice that covers Titan, we can ascertain if there are any clues to what may be in or once was in the atmosphere. And the best way to do this is with a drill. And so it would be a small drill that would just sort of drill through the surface of the ice. And what will be important here is to make sure several preliminary tests are done to make sure the drill runs smoothly in ultra cold conditions, because on NASA's website, it mentions that sometimes these drills that scientists try to use for this reason often get frozen in place. So it would be really important to run those tests to make sure that this isn't a possibility for us. And then lastly, in terms of instruments, we will be using a microscopic imager. And a microscopic imager is basically a combination of a microscope and a CCD camera, which is basically a digital camera. And so the reason why we'd be using the imager is we're hoping to take a kind of in-depth microscopic analysis of the surface of Titan in order to give us some clues about its atmosphere, kind of working from the ground up. So for example, scientists discovered a strange molecule in Titan's atmosphere, and it's called C3H2. And C3H2 is a combination of carbon and hydrogen. And even though it's been found in patches around the galaxy, it's never been found in a world's atmosphere except for Titan. So scientists were really excited about this, and this just happened. This discovery was just made public last year. So C3H2 reacts really easily with other atmospheric particles, and this is why scientists think it hasn't been seen before in other atmospheres except for Titan's. So maybe by using the microscopic imager with Titan's surface molecules, maybe we can gain some kind of understanding of things that are in Titan's atmosphere, or maybe what happened in the past. So Cheyenne?
All right, so now I will be discussing how we're going to use these tools, or how these tools could help us answer the questions we are asking about Titan's atmosphere. So to begin with, one of the first questions we're asking is, can Titan's atmosphere ever have a ozone layer, or can the orange haze that is dominating the atmosphere currently, could that ever turn into a ozone layer? So in order to determine this, the best tool we have is the REMS weather station, because it has so many different components, such as the UV radiation monitor, the air pressure monitor, and the temperature monitor. In order to determine whether or not Titan is developing a ozone layer, we would mainly be looking at UV radiation. This is because, as we know, here on Earth, ozone protects biological organisms from the harmful effects of UV radiation. And it's also said that if the ozone layer never formed, life probably would have never formed here on Earth. So it's very crucial that we determine whether or not Titan will ever develop an ozone layer, or if the orange haze will ever turn into one. Now, it's also important to note that just because the ozone layer here on Earth contains oxygen, or it needs oxygen in order to develop, This may not be the case on Titan because many scientists have argued that life on Titan could look completely different than what we know life as on Earth. One of the main reasons is because of the liquid methane lakes and rivers. And because of the fact that water is not volatile at all on Titan, so life could look very different. So we might not need to necessarily look for oxygen itself, but we just need to look for the development of some sort of layer in in Titan's atmosphere that could prevent UV rays from damaging any kind of organisms that start to take root on Titan's surface or in its ocean. So one of the first things we'd be looking for is we'd be monitoring the atmosphere using REMS. And obviously, one of the things we'd also be measuring is temperature, because if there is an increase in UV radiation, most likely the temperature is going to go up slightly. We don't really know what the effect would be on Titan, but most likely, if UV radiation were to go up, a lot of hydrocarbons, a lot of the organic chemicals that are found on Titan as sand and other materials like that, they could disappear. And as we know, in the upper layers of Titan's atmosphere, a lot of the uh, methane is destroyed by UV radiation. So we might see a temperature increase. Also, if there is the development of an ozone layer, or like a very gradual development, because our mission probably would not be able to witness it, but we would probably be able to determine whether or not we are headed in the right direction. So the ultimate answer won't be is there an ozone layer or is there not. It's more going to be, is there something here that we can work with. So that something would be the development of of a more stable climate on Titan, because as we know here on Earth, ozone does balance temperature. Um, and it heats the stratosphere, so we might also see Titan's climate and its very cold and rigid temperatures get warmer, and maybe even see some of the non-volatile water features such as the rocks. Maybe they could even turn volatile. That's just something we'd have to wait and see. But that's something REMS could potentially measure. It's whether or not UV radiation is going up, whether temperature is going up, and if there is an increase in air pressure. Because as more molecules are accumulating in the atmosphere, that more pressure would be accumulated. So from there, the next question we want to determine is whether or not the methane supply on Titan is depleting, or if it's replenishing itself, or if it's increasing. People don't really know where the methane is coming from. It's kind of a mystery right now, and the current composition of Titan's atmosphere is only 5% made of methane, and that 5% is also mixed in with a lot of other smaller hydrocarbon molecules that are created through the splitting of nitrogen and methane molecules up in the upper levels of the atmosphere. So because of that, people don't know whether or not Titan is losing its methane. And if it were to be losing its methane, the REMS could also help, or whether it be gaining methane, sustaining or replenishing, um, or losing. The REMS would be the best option here as well, because REMS could just monitor the temperature on the planet, um, and maybe even UV radiation, because as we know, methane is a greenhouse gas. So as if more is accumulating up in the atmosphere, if it's somehow being released by outgassing, even though there isn't any recent signs of volcanism on the planet, if outgassing is a source of methane, maybe geysers in the planet's surface, or even the heavier hydrocarbons that fall to the surface as sand, maybe they're being heated up by the planet's interior and then being put back into the atmosphere as methane. If any of these processes would be taking place, This would mean an increase in methane in the atmosphere, and that would in turn lead to an increase in the greenhouse effect, which would then lead to an increase in temperature overall, and that's something REMS could be able to pick up on. Also, methane would be able to absorb a lot more UV radiation. So REMS could also detect like a higher level of UV radiation in the atmosphere, which could indicate that methane levels are ample and, they're not going anywhere. Or on the other hand, we could see a significant decline in temperature. It's argued, some argue that if Titan loses its methane, the entire nitrogen atmosphere could freeze up and it could eventually just lose its atmosphere altogether. So this is something we should keep an eye on. And again, REMS could help us determine this, because it would closely monitor the temperature on the planet and the UV radiation, which would help us determine the amount of, or just give us a general idea of how much methane is out there in the atmosphere. Now, if our instruments don't pick up any kind of drastic changes, let's say things just stay constant throughout the duration of the study, this means that somehow Titan's methane reserves are uh, like replenishing themselves, because as we know, the splitting that takes place, that destroys the methane. So if things are remaining constant, that means somehow there's like one or two sources, a few sources that are replenishing the methane in a very exact amount. And this would be also very interesting. And our work could lay the groundwork for future exploration and for future scientists to see what they can find based off of our research. So moving on to the next question, we want to know whether or not. So one of the most important things about Titan is its liquid oceans that exist below the frozen crust of the of the moon. Sorry. So we want to determine whether or not this ocean can ever be thawed out, or if it can ever come to the surface. If the surface of Titan can ever melt, not completely, but just so much to the point that the oceans can reveal themselves. Because as we know, here on Earth, a lot of the first origins of life came from the ocean. And with all the similarities between Titan and Earth, it would not be surprising if Titan's first life forms did arise from its oceans. But in order for these oceans to come to the surface, if for them to be visible, and not below the surface below its frozen surface, we would need the temperature of the planet to significantly increase, because as of right now it's about negative 200 degrees Fahrenheit. And as I mentioned, it's so cold that water is just a rock on this planet. It's not volatile at all. So that just gives you an idea of how cold it is. So we want to determine whether or not it's possible for Titan to heat up, or if for its atmosphere to heat up more specifically, to the point where the frozen surface could thaw out to the point, or could develop enough heat where it's no longer a frozen, harsh climate on the world, and there's more liquid oceans rather than just solid frozen surfaces. So one of the main ways we would determine whether or not this is possible for Titan's oceans to ever come out from below the surface would be through the use of the TIGA. And this would be we'd also need the drill and the robot arm to collect samples of the frozen surface in order to bake them in the oven and get them to release the heavier gases. What we'd be looking for is basically any kind of greenhouse gases that could be released. As we know, here on Earth, a lot of carbon and other greenhouse gases are frozen away in our ice caps, which is why global warming here is so concerning. That if those ice caps melt, there will be a huge increase in greenhouse gases, which will lead to the planet's temperature going up. Now, we believe something similar could be seen here through the use of the TIGA. We could see that if we are able to find any kind of carbon, or just more methane in general, or maybe even oxygen, we're not sure what we would find. But if we are able to find some sort of greenhouse gas that could capture a lot of the heat uh, on Titan, in its atmosphere, we could see the possibility of all the frozen surfaces melting, not all of them completely, but a lot of them melting. And we think this could lead to like a self-fulfilling heating cycle, because if if little by little more and more greenhouse gases that are trapped inside these different frozen surfaces, depending on how they're distributed, this could create a very unique landscape if temperatures ever got to a point where Titan's very frozen thick surface could ever melt out. But that's very speculative. There's also the possibility that the Tiga finds nothing, and we would expect this to be the case because our drill is pretty small. We weren't able to get the bigger drill due to weight limits. But even if we are able to find a significant amount of methane frozen away in the surface, and which is very possible at the upper levels of the surface because there are methane lakes, maybe they just froze and they're just settling at the top of the surface. So we would still be able to find that methane. It would be a bit less exciting because like we wouldn't find any new molecules, but it would still indicate that the planet does have room to heat up. Um, and so yeah, so if we were able to take those samples and we probably wouldn't be able to find any kind of greenhouse gases. But what we did think we could find is a lot of hydrocarbon molecules, because since they fall to the surface of sand, we would use the robot arm to collect samples of that and study them with the microscopic imager in order to determine, in order to make a very in-depth catalog of all the different hydrocarbon molecules that have been produced on Titan. And this would be able to give us a more in-depth understanding of what's going on in Titan's atmosphere. Because we'd be able to understand, like if we were able to find certain hydrocarbons, we could work backwards and then be able to understand the atmospheric processes that led to the creation of that hydrocarbon itself. And this is something that we expect to be more likely because there are more abundance of hydrocarbons on the surface, and uh, there is a theory that hydrocarbons are being heated by the planet's interior to be released back into the atmosphere as methane. So that's how all these different instruments such as REMS, TIGA, the drill, and the robot arm, microscopic imager. All of these instruments are very crucial. Without one of them, we probably couldn't be able to do any of our experiments. It would leave us incomplete. And one thing I just want to point out is that although our experiments won't be able to find very finite answers, like very yes or no answers, I think we will be able to lay the groundwork for future studies to take place, and work off of what we have already discovered. And many scientists already believe that the orange haze that's in Titan's atmosphere right now may be very young. So we could be we may be studying Titan at the very point where it's beginning to form into a body where it could sustain life. So we're very patient with our findings. We're not really looking to find anything crazy, but Titan is full of surprises. But regardless, we do think all these tools together could really produce some meaningful results for us. So uh, and so in conclusion, Titan's atmosphere has a million questions that could be asked of it. We were restricted by the amount of weight and different kinds of instruments we could take, but nonetheless, we can make the most of what we have and really learn a lot of exciting things about the planet and see if there even is a prospect of future life. I think, and I think my group mates could agree that even the possibility that another planet is going through some of the same phases that our planet went through in its early days, billions of years ago, is very exciting. Even if we don't find out tomorrow whether or not life will exist on the planet, I think it's very interesting that we're able to study the planet's atmosphere by studying things on the ground and making use of the instruments we were able to take. But overall, first we discussed what we know about the planet's atmosphere. Then we went on to talk about our group's mission objectives. And after that, we discussed the various instruments our group will be using. And lastly, we talked about how those instruments are going to help us answer the questions we are asking, or at least get an understanding of, or get an understanding of what we're asking. So overall, that's our presentation. Thank you for listening. Stop share and hold on.